Hello. So this is chapter 23, and this is population evolution, basically how we see evolution happening within population, and then a few different things that we observe that we can know that population evolution is happening within the population. So this is part one. So really quickly, these are some of the stuff that you need to know. How mutations and sexual reproduction each produce genetic variation, and the condition for Hardy-Weinberg equilibrium, and how to use Hardy-Weinberg equation to calculate different allele frequencies and to test whether a population is evolving or not. So, let's talk about not the larger picture. Let's talk about in a smaller scale, microevolution. Microevolution right now, this slide is, oh, my apology. Microevolution is talking about changing in allele frequencies of a population over generation. So as you can see, one of the example that human through artificial selection can create this microevolution is dog species. So we breed different kind of dogs for different kind of traits. So as you can see, if somebody prefer their dogs to have long hair, we will actually specifically select dogs with long hair and breed them. So they will have their offsprings will have long hair like this. And similarly, if we want dog with more power, more strive, then we will breed for this kind of species and so on and so forth with different kind of skin tone, with different kind of characteristic. So this is microevolution. Something happens within the population that's much smaller, and then it happens much quickly over generations. Microevolution. So this is what we'll be talking about. So this is the smallest unit of evolution, microevolution. Okay, this is different again than macroevolution. Macroevolution is talking about the big picture, much larger scale. Microevolution, much smaller scale. So a few things that we'll be talking about here is, well, back in time when Darwin realized evolution is happening. Well, he didn't use the word evolution, but he realized there is some kind of modification happen with the descendants of different species. He actually doesn't know what's going on. How are the organism be able to pass on their traits to their offsprings? So he was not able to figure that out not until 1866. Mendel, the monk, famous monk, published his paper on genetics. So Mendel kind of started this popular trend, which later called Mendelian genetics, which supports Darwin's theory of evolution is actually happening. And how he concluded was because there is a genetic variation, and that happens throughout different generations. So again, Darwin didn't know what's going on and knows something's happening. Mendel comes out with a theory of genetic variation that's the cause of evolution. So that's how they are related. So there are a few sources of um, genetic variation. So we have first thing point mutation, which is this one, changes in one base. So when we have DNA replication that time, we have that one base change out of thousands. Okay. And then that could cause some kind of disease or just mutation, modification of traits in general. But in this case, my example, it's the sickle cell. So sickle cell is caused by one base mutation in a gene. So that's why the disease comes about. Second sources of genetic variation is chromosomal mutation. Okay, whether it's deleting, duplicating, disrupting, or rearranging. Okay, and this is very critical. Mostly, usually lead to very harmful outcome, and because this happen not just one base are changed, but the entire chromosome it's mutated. Okay, as you can see, the entire chromosome, which contains many different vast amount of DNA data. So when something is deleted, something is duplicated, something is bound to failure. So again, very harmful, usually harmful when you have a chromosome mutation. Okay, number three, sexual recombination. So contributes to the most of genetic variation in a population. Okay, so if you can think about it, well, basically this is telling us that, well, when you have different combination of genes, you're going to have different genetic variation, which makes sense because think about a different possibility that we can create just with, let's say, two numbers. Okay, and then now let's multiply that by 1,000. So we have two sets, 2,000 numbers. We can have even more possibility. Okay, just if you don't remember what this is, just think about Ben and Jerry. They have like so many different kind of flavor, and if you just want to create, let's say, a three-tier ice cream cake with different kind of flavor, then you have many different combination that you can choose from. So that's kind of like a more food related example about sexual recombination. And within sexual recombination, we have three major things that causes sexual recombination to be more genetic, to be most genetic variation. So one is crossing over, and this is talking about. I'm sorry, I don't know why I did keep doing that. Crossing over, we're talking about when the chromosome part overlap and then something happened, so they actually they actually changed their location of the DNA. So some of the DNA went to, let's say, chromosome number 1. Some of the DNA went to chromosome number 2, when it should have stayed just chromosome number 1 altogether and chromosome number 2 altogether. So that's crossing over. Number 2, that's independent assortment of chromosome. Okay, this is talking about independent line up of the chromosome. This is not talking about DNA data exchanging between chromosome. So that's the big difference between independent assortment of chromosome and then the crossing over of chromosome. Third thing is random fertilization. Again, this is talking about a combination that changes due to the ability out there, the possibility and the opportunity out there. So we actually have different traits that we can change and exchange between and within the population.